Okay, and so now what we need to do is actually add a NuGet package to our data project. So if we expand dependencies here, you can see that we actually don't have any NuGet packages. So we'll go ahead and right click on the project, lambdaforums.data, and then we're going to go ahead and select manage NuGet packages. And we're just going to search for Microsoft.EntityFrameworkCore.tools. And then we'll install this Microsoft.EntityFrameworkCore.tools NuGet package. And at the time of this recording, I'll be using just version 2.0.0. And we'll go ahead and accept. And now we should see under the dependencies list here, we have Microsoft Entity Framework Core tools available. And I'm also going to go ahead and install Microsoft.ASP.NET.Core.all. Sorry, ASP.NET.Core.all. You should see it here. And we'll go ahead and also install the latest stable release as well. And once again, we'll go ahead and accept the license agreement. Okay, and we can close the NuGet package manager. And for now, we'll go ahead and close this class 1, which was just an empty class that was created when we created our class library. And I'll minimize the dependencies. And so now let's open up this application DB context file. And we have some errors here that we'll fix in just a moment because of the fact that we moved just part of what was required over into this data project. But first I want to talk very briefly about DB context. So we'll be using Entity Framework as our ORM. And that's the piece that's actually going to be allowing us to do all of the interaction with the data that is in our database. So it'll be doing like the querying, the inserting, updating, and deleting of that data. And so it needs a way to basically map the entity models, the way that we represent objects in C# to the models that we have actually defined in a database. And we're actually going to be defining everything in a code-first fashion here with .NET Core. And so what that means is we'll actually define classes for entity models in code, and then we're going to run database migrations, and basically Entity Framework is going to take a look at the models we've defined, and then it's going to essentially create our database schema for us based on those models. So our DB context class is basically the main class that's going to be responsible for interacting with our data as objects. And so you can kind of think of a DB context as a particular database, and then we're going to define something called a DB set, or a series of DB sets in our DB context class here that will essentially represent tables, if you will. And in fact, Entity Framework is going to use all this information to actually build out the various tables and the columns in whatever database we decide to build. So let's go ahead and start to do that. The first thing that I like to do though is to go ahead and fix these errors. So here you can see Entity Framework is letting us know that it can't currently resolve this application user symbol. So let's go ahead and bring that over. You can kind of get a clue for why that's happening here, since we just essentially copied this folder from our web project that it was in this models namespace. So if we look up in the web project in the models folder here, we actually have the definition for application user there. So what I'm going to do is create a new folder in our data project, and we'll call it models. And then I'm going to go ahead and grab application user and just drag it over into this models folder. And again, we'll delete it from models in our web project. So the only models that I want in our web project are actually view models. And all of our entity models will be represented in our data project. So you can kind of think of the models in our view models folder here, or our models folder in the web project, as representing a structure for the data that we'd like to display out to the page. And the models in our data project are our entity models, which actually represent sort of the overall architecture or the relationship between different objects in our system, as well as the way that we're representing it in our data store. So what I'm going to do is actually go ahead and first of all remove this protected override on model creating method. We're not going to do any sort of custom configuration with that. And for the purposes of this series, I'm also going to be removing ReSharper. But I would like to mention it here. If you've developed in C# in the past and you're probably familiar with ReSharper, it's a fantastic product. and it makes things like refactoring in particular quite a bit easier. But for the purposes of this series, I'm just going to assume that everyone is using the standard Visual Studio 2017 and may not have ReSharper installed, so I'm going to go ahead and just disable it for now. Okay, so now what I'm going to do is we go to the top of the file here and Control period. We can actually remove some of those unused usings, and then if we come down here, what we're going to do inside of our application DB context class now is to actually define those DB sets that we'd like to map to our SQL database. And so, for instance, we have this application user model already created for us, so we'll go ahead and create a DB set for that. And so we'll just create a public DB set of type application user, and we'll call this application users. So you can think of this DB set again as the table of users in our database. And then what I'm going to do is now create entity models for the remaining entities in our forum project. And so we only have a few of them, so we'll go ahead and just add them all now. We'll go ahead and add a class here, and we'll call it forum. And we'll go ahead and make it public. And now we get to define a set of properties that would define this forum object. And of course, these properties will be represented as columns in our SQL database here very shortly. So the first thing we need to do is define an ID property. So we'll just make that an int, and we'll go ahead and define that. Next thing that a forum should have should probably be a title. And then we'll have maybe a description for the forum, and we'll have a time or a date time that the forum was created. So I'll just call that property created. We'll get set. And then I'd also like to have an image for each of the forums, and those images will be hosted in the cloud. And so we'll basically just provide a URL to that particular image for each of the forum instances that we have, or forum objects that we have. So we'll go ahead and create an image URL property here as well. So now a forum basically exists to hold a collection of posts. So we'll need to go ahead and create an enumerable collection of posts, which of course is a type that we need to create. And in fact, I'm going to make this a virtual property. This will allow us to lazy load the property in any framework, and we'll take a look at that a little bit later. But in a sense, when we ask for the forums, we will also now have to explicitly include the post if we want the post object on that forum object. So post will be a navigation property now and will be lazy loaded. So let's go ahead and create this post type, and we'll just store that in another C# file here. So we'll add a class called post. Of course, like all of these classes, we'll be making it public. So each post needs an ID, and I'll go ahead and make it standard camel case here. And then we'll have a title to the post and some content to each post. Then we'll have a date time to represent when the post itself was created. And then we need to know who actually wrote the post. So we'll create another virtual navigation property here over to an application user. And if we control period here, we can bring in the application user from the models namespace that we're in. And you can see we're not getting an application user, probably because we didn't actually correct the namespace in our application user class. And so yeah, this should actually be lambda forums.data.models, and we can go ahead and clean up the usings in this file as well. And we'll go back over to our post object. Okay, so you can see our application user is accessible, and then each post will also be related and posted to a particular forum. So we'll create a public virtual forum, and we'll also just call it forum. And then what I'd like to do is to be able to associate a series of replies to each post. And we could actually think of replies themselves as posts, or we could think of them as separate objects. And that's an interesting question. It might seem most logical at first just to make replies also a type of post. But I think what I would like to do, in particular for the way that our form is set up, it's almost like as a coding forum, perhaps it's more of a question-answer type forum, that perhaps this idea of a post is still something distinctly different than a reply to a post. And so I think I'll go ahead and break that out into a separate object. And so in that case, we'll have a public virtual IEnumerable set of post replies. And just correct some spelling errors here. And we'll call those replies. And now we just need to make our post reply objects. Let's go ahead and do that. So in our models directory, add a new class, and we'll call it post reply. And go ahead and make public. And now we'll have IDs on each reply, the content of the reply, which will be a string, a timestamp there, a date timestamp, and then some navigation properties here over to the particular user who posted the reply, as well as the post for which the reply itself was posted. So we'll go ahead and clean up some of the usings here, and so this should adequately represent a simple post reply. So I think that those are all the entities that are really necessary in our case to create a basic forum setup. So we've got users, we've got the forums themselves. We can clean up the usings here. And so the forums have a collection of posts on them, and the posts are posted by a user to a particular forum and have a number of different replies potentially. So we have an object for that, and replies themselves are posted by users and correspond to an individual post. So again, if you're structuring it a little bit differently, you may just have some entity models with forums and posts only, and then represent replies also as a type of post. But as I said, for our case, we're just going to go ahead and break that out into two separate entity models here. Okay, so now we should head back over into application DB context. And what I'm going to do is go ahead and remove this using. And then we'll control period here over on application user and bring in our models namespace because our application user model is now inside this models folder, which is acting as a namespace provider. And now what I'm going to do is just create DB sets for each of those entity models that we just defined. So we've already got our application user. Now we've got a collection of forums, posts, post replies, and that should do it. Of course, if you wanted to implement other features in your application, say like private messaging between users, or maybe you wanted a separate object to represent user profiles or something, then you would just continue to add entity models to your models folder here, and then define new DB sets here in your application DB context class. So one thing to note is that this is not just a standard DB context class, but in fact it's inheriting from this identity DB context base class, which takes this application user type, and essentially, since we've implemented identity with the template that we used here, and so we'll have some tables in addition to the DB sets that we've defined here in our SQL database. Okay, so now let's go ahead and actually wire up our SQL database and run our first migration so that we can get these tables actually into a SQL database. So what we're going to do is, if you remember back in the web project here, in our startup class, if we scroll up, you can see that some references to application DB context are going to be broken now. And so for this, we actually need to add a reference to this class library that we just created and created our DB context within. So what we're going to do is go ahead and right click on Lambda Forums, which is our web project, and we're going to add a reference to our Lambda Forums.data projects. We'll select OK here. And now what we can do is just control period if it doesn't already come in. And now shortly you should see application DB context available to us, and we can bring in the namespace for application user here with just control period, and we'll make sure that we can use that, and that will be included at the top of our file here. So we'll no longer be requiring a reference to the models directory in this web project, so I'll control period to remove unused usings here. And now what I'd like to look at is, if you look under the configure services method, let's take a look back at our add DB context, which is getting called on our service collection here. So we're going to add DB context to our services, and we're going to use SQL Server, and we're just basically going to grab a connection string here from our configuration, and we're going to grab the one with the key default connection. So this method is going to look inside a JSON file for a connection strings node and then grab the one called default connection. So let's go ahead now, and we can find that connection string actually in our app settings.json file, and in particular currently the app settings.development.json file. So we actually don't see it in development.json, but in app settings.json. But what I'd like to do is to actually copy this into our app settings.development.json as well. And in fact, I'm just going to remove it from app settings, and we're going to put this inside of app settings.development.json. So I'll paste that here. And we can keep it named default connection if you like, but instead of the database being this very long generated database name, we have the option to rename it. So that's exactly what we're going to do. I'm just going to go ahead and highlight everything before the semicolon on the database, and we'll just call this Lambda Forums.dev. This will be our development database. So I'll go ahead and save this. And so note now that our connection string is only in our development file here and not in just the standard app settings.json. That's still okay because our app settings.json is actually going to overwrite anything or add anything that's not in our app settings.json file when we run our application in development mode. And all that is actually bundled up in the functionality of when we run our default configure builder. So if we take a look back again in our startup.cs class, our program.cs class now, when we're running this create default builder, it's going to add our app settings.json file, and then on top of that it's going to add our app settings dot whatever environment we are running in .json file. And so in that case, this connection string will get added when we're running in development mode. We'll look back at the program file here and add a new JSON file that contains some of the connection strings for our cloud storage when we get to that section in a little while. For now, we can go ahead and close this, and I'm going to go ahead and close some of these other windows. And what I'd like to do is to go ahead and create our first commit. So if you head to the command line and cd into your project directory, you'll notice that we should already be on master branch if we initialize this project with the Git repository. And we can run git status to see everything that we have added or changed here. So what I'm going to do is just go ahead and git add dot to add everything that we've changed with this directory as the root, and then we'll make a new commit here with git commit -m initial commit, maybe like create data project. And if you're hosting this on GitHub, then you can go ahead and create a new GitHub repository and push to it if you wish. Okay, now what I'm going to do is go ahead and build the project. So right click and we'll build the whole solution actually. And we'll see if we have any errors outstanding. Okay, so we do have one, so we can click on error list. Actually, we've got quite a few here, so it looks like we're having namespace issues in our account controller. and our managed controller. So yeah, that's to be expected because we move the application user out of the web project. So this is going to be a pretty easy fix. We can just control period here to correct the usings in this file, and control period on any instance that's broken here to bring in the correct using. So that takes care of the account controller. Now we can do the same over in the managed controller. So control period at the top, and control period here on application user to bring in the correct directives. Okay, so let's go ahead and build our project now. And since everything's building, the next thing I'd like to do is to go ahead and run our first database migration. So to do that, we'll head over to the Package Manager console, and for default project, we're going to select lambdaforms.data. If you remember, that's where our DB context lives, and that's what Entity Framework is going to need to see in order to start generating our SQL for us. So what we need to type here is add-migration, and I'll just call it add initial entity models, and we'll hit enter to run that command. And so you can see what's going to happen now is inside the migrations folder, which actually just gets generated for us in our data project, we have some new C# files here, which are actually going to kind of illustrate the type of SQL that's going to be built. So we don't need to actually read through this verbatim. It's basically just code that gets auto-generated to do things like create tables. If we were changing the schema in other ways, say dropping tables or dropping columns, you'd see similar methods for those things here on each of these migration builder objects. So these migrations are basically a way to kind of like freeze in time any type of change that we make to our database schema. So we can always roll back to a particular database migration as long as we keep these files around. And again, this is all code first. So Entity Framework is looking at our entity models from our DB context and then saying, like, you know, for instance, hey, I don't see this database, and so I'll create a new database, and then I don't see these tables with these columns based on these properties that are in your DB set, so I'll go ahead and create those as well. And so in a way, it's kind of doing like a schema compare, if you will, against the way that you've structured your entity models in C#, and then attempting to run those updates on a database. Now, this isn't a schema compare in the sense of comparing two actual SQL databases against each other and then making some changes. I just kind of think of it that way in terms of the way that you structured your code, how these migrations then get built. So if your migration ran properly, then you should now just be able to say update-database. And you'll get quite a lot of logging out to the command line, and then you should just see done. So we shouldn't see anything actually change in the solution at this point. Everything that just happened as a result of Entity Framework using the connection string that we supplied to our local DB instance, and then it actually just created that database. So let's go ahead and take a look at that. We can open up SQL Server Management Studio to actually take a look. So that's coming up here, and then under connection strings, what we're going to do is connect to the server localDB in parens and then / MS SQL localDB. You should be able to confirm that you have MS SQL localDB installed if you just head over to the command line, and if you type in SQL localDB info, you can see, you should be able to see a list of the SQL databases actually installed. And so in this case, we can see that we have MS SQL localDB running. If it's not running, then you should be able to type in SQL localDB start MS SQL localDB. And then you should see that localDB instance MS SQL localDB is started. Okay, so it may be running on your machine already if you've just installed it with SQL Server or with Visual Studio. In any case, we're going to go ahead and use that as our server name and just use standard Windows authentication to connect. And now under our databases folder here, you should see the database that you just created. So I've got a few other databases for instance, the demo for this project that I showed at the beginning of this series, as well as some other databases here. But the one that we should have just created was called lambdaforms.dev. So if we expand this and then take a look under tables, we can actually see tables corresponding to our forums, post replies, post, as well as a whole bunch of things that have the prefix ASP.NET. And this is all tables that were brought in by that identity. So our DB context, which was inheriting from that identity DB context base class to handle all of our user authentication. So this is where our ASP.NET users and user roles and things like that are living. So let's go ahead and expand forums, and you can see under columns, we have columns for each of the different properties that we defined on our entity model. So for instance, if we look back in the code, under models, and then in forum, for instance, we have the primary key ID, and then we have like title description created on an image URL for which we have columns each in our new database.